So today I would like to go over that midpoint, the distance formula, and the Pythagorean theorem. Okay, so let's take a look at this slide right here. So the midpoint formula is just like the way that we find out the average value of two quantity. So like the x value, so x1 plus x2 over 2, comma, y1 plus y2 over 2. So anytime they want to get the midpoint, always combine the x values together, divided by 2. And same thing happened with the y value as well. Okay, so now check it out, one of the example here. So find the coordinate of midpoint segment PQ with the endpoints p equals -8, 3 and q -2, 7. So this one identifying the value x1, which is -8, x2, -2. So combine those two values together and then divided by 2. And then same thing happened for y1, y2, so y1, which is 3, y2, 7, combine them together, divided by 2. So evaluate it, -8 plus -2, so that's -10, divided by 2, so you get -5. And then 3 plus 7, combine them, so that's 10, divided by 2, so you get 5. And this one is just like visualizing, what's happening. So once you plot those 2 points, so it's connected, so it's always the line segment. So the midpoint, -5, 5, which is in quadrant 2, so it's right up here. Okay, so now let's see what else that we have for this. So here's another example finding the midpoint in between E and F. So basically the same kind of idea using that midpoint formula. And this one, example 2, is a little bit different. So M is the midpoint of x, y, x segment xy. X has coordinate 2, 7, and the midpoint has the coordinate 6, 1. So this one you got to be very careful. The midpoint is actually given already, and then one of the endpoint it's also given. So instead of plugging the number x1, x2, so this time we need to find out the value of x2 and y2. So what I got here for step 2 to set up, so 6, 1 equals 2 plus x over 2, and then 7 plus y over 2, because we're looking for the endpoint. Okay. So the way to solve for this, we just want to set each one of those positions equal to the midpoint value. So 6 equals 2 plus x over 2. So what you can do here, you can cross multiply, or you can just simply multiply both sides by 2. So we got 12 equals 2 plus x. Subtract 2 both sides, so we do have x equals 10. And then same thing happened with the y coordinate. So 7 plus y equals 2. 7 plus y over 2 equals 1. So you want to solve for y. So basically we just want to do this separately. So we'll be able to solve for x and y. So multiply by 2 both sides, so we do have 2 equals 7 plus y, subtract 7, so y equals -5. So 10, -5, which is the other endpoint. So the next one I would like to talk about is the distance formula. So for those you might be wondering, well, how do we get the distance formula? So this one, it's based off the Pythagorean theorem. So before we go through this formula, let me show you the proof for this kind of distance formula. Okay, so let me go to this page. So let's say that we do have a coordinate system. Okay, so the xy plane. And we do have 2 random points. Okay, so one is considered x1, y1. And then the other one here, which is considered x2, y2. So once you connect them, so then that'll be a line segment. And also one thing that I can do here, so we can always come up with the right triangle. So let's say that we do have a right triangle. Like that. So you might be wondering, well, what's happening with the distance here? Well, this one is just consider, well, this point here is considered x2, y1. So the way to find the distance is just x2 minus x1. And the distance right here, then that'll be considered y2 minus y1. Okay, so this one we don't know what that is. So let's say that's C. And x2 minus x1, so let's say that it's just A. And this one, y2 minus y1, then that's B. So according to the Pythagorean theorem, it's a squared plus b squared equals c squared. And I'm sure you guys are pretty familiar with that. And when can we apply the Pythagorean theorem? So Pythagorean theorem is only used for the right triangle. Okay, if we see like a obtuse, acute triangle, then we have to apply another theorem. We'll get to that in the later chapter. So a squared plus b squared equals c squared. So one thing that we notice, a is the same thing as x2 minus x1. Okay, so exponent, we just want to carry that along. B, so instead of using b now, so we're using the replacement, y2 minus y1. Again, exponent, just carry that over. And then c squared, that's what we're looking for. So in order to solve for c, so what we can do, we take the square root on both sides. Okay, so c, that means it's just the square root of this whole quantity. So this one, I just put a ditto, same as the one from above. And guess what we found here? So that would be the distance formula. Okay, so going back to what we have right here. So the distance formula, that's exact same thing as the one I showed the proof for. And now let's do one example like this. So let's say that you want to find the distance in between 2 points, the line segment. So we do have f 1, 2, g 5, 5, j -4, 0, k -1, -3. So basically find the distance. So using the distance formula by plugging a number, x2 minus x1, so 5 minus 1, quantity square, y2 minus y1, 5 minus 2, quantity square. So, and the rest of that, you just need to evaluate it algebraically. So 5 minus 1, so then that's 4, 4 square, 16. 5 minus 2, 3, 3 square, 9. So 16 plus 9, 25. And square root of 25, so it's a perfect square number, which is what? 5. And the other one pretty much doing the same thing, jk. So plugging a number, -1 minus -4. So then that will give you 3. 3 square, then that's 9. -3 minus 0, -3, quantity square 9. 9 plus 9, 18. But unfortunately 18 is a non-perfect square number. Break it apart, 9 and 2. So square root of 9, then that's 3. And square root of 2, just leave it. So one thing that we notice, two different distance, so therefore FG, it's not the same as JK, so there, that means they're not congruent, okay? So you see the slash, that means it's not, okay? Not congruent with that JK. So for the distance formula, it's quite straightforward. And then the other one is just like the similar examples. Okay, so the right triangle, we always have 2 legs and 1 hypotenuse. Okay, so 2 legs, A, B, and then C, which is the hypotenuse. So using the Pythagorean theorem, as what we talked about, things that you guys learned before, it's based off the distance formula, using the first method, distance formula. And then second method, using the Pythagorean theorem, so just find out the distance of each side length, A, B, and then plugging that to the Pythagorean theorem. So you'll be able to find the distance of the hypotenuse. So this one is quite straightforward. Okay, so nothing special. So mainly for the second half of 1.3, so all you need to focus on, it's about the midpoint, the distance formula, and also the Pythagorean theorem. So here's another example for the distance formula. We're using the Pythagorean theorem. So in case that you guys want to do practice, so here's some of the practice problem that you have. So find the coordinate of the midpoint using the midpoint formula. Find the coordinate of point L, so the midpoint is given, just like the problem we did. Distance formula, so this one you want to round it to the nearest 10. So that means it's rounded to the 1 decimal place. So using the distance formula. Coordinate, so the points are given, so you want to draw the diagram. So find out the right triangle and then try to get the distance of the side length of the triangle, and then after that you want to find the perimeter. Okay, so this one is some of the problem you can practice with. And here's another one using the distance formula. Alright, so thank you for watching the video today. So if you guys have any questions, so just let me know. So you can just put it onto the comments for the video. And if you guys do like the video, so please subscribe to the channel. Alright, so I do have more valuable lessons for geometry, regular geometry, and also geometry honors. So they're all coming up. Okay, so thank you for watching it today. So I'll see you guys next time.